All right, let's look at a couple of examples of method of undetermined coefficients. All right, so we have this non-homogeneous equation, and what we want to do is find the form of the particular solution y sub p. All right, so in order to find the form of the particular solution, we need to know what the complementary solution is. All right, so let's do that. So we're going to do a characteristic equation and pretend that the right hand side is equal to 0. So we have r to the fifth minus r cubed is equal to 0. So this would be the characteristic equation, and we're going to factor out in this case r cubed, common factor. So you have r squared minus 1 equal to 0. And we can actually factor out the second part a little bit further. So you have a r cubed times quantity r plus 1 times r minus 1 is equal to 0. All right, so which tells us the r value must be r equals 0, right? But this is repeated 3 times, so I'm going to just say 3 times. All right, and also plus or minus 1. All right, so which means that the complementary solution, so y sub c, is going to be, right, r equals to 0, e to the 0 is 1, so you're going to have a constant. I'm going to call it C1. I'm going to just C1. And then since it's repeated 3 times, you're going to have also have C2x. And then also C3x squared. Right? So since it's repeated 3 times, you have to have those. And a positive 1 and negative 1. So it's going to be C4 e to the positive 1, so it's going to be e to the x, and also c5 e to the negative x. Right? So this is the complementary solution. So in order to find the form of the particular solution, we have to make sure that the particular solution do not have a common element with the complementary solution. Right? So by looking at the right hand side, right here, right, we think of all possible derivatives, right? So derivative of e to the x is always e to the x, so e to the x should be there. And also derivative of 2x squared minus 5 is going to be, you're going to have x squared term, and you're going to have x term, you're going to have a constant term. So initial guess for a particular solution would be y sub p is equal to, right? So we would have a constant term. So I'm going to call it, let's see, a1. Let's call it a, and then bx plus cx squared, right? Because you have a 2x minus 5, so you will have that. Then we have another one plus let's say d times, let's try e to the x, right? This would be an initial guess, right? But what happens is, since we already have a constant term and the x term and the x squared, so what we do is we have to take these guys and multiply by x to the some power, so that it wouldn't have any overlap, right? So which means that we're going to have to multiply this guy by x cubed, right? So that it wouldn't have overlap, right? And the same thing here, e to the x has an overlap with the complementary function, so we would have to multiply this guy by x, right? So therefore, particular solution, at least the form of the particular solution, is going to look like this. A x cubed plus b x to the fourth plus c x to the fifth plus d times x times e to the x. All right? So this is the form of the particular solution. All right? All right, let's do another one. All right, so very, very similar. All right, so first, what we need to do is we need to find the complementary solution. So let's go ahead and do that. So we have r squared. Oh, sorry. All right. So you have r squared. All right, and plus 4 equals 0. All right. So since y squared is equal to -4, so it's going to be an imaginary solution. So you're going to get r is going to be plus or minus 2i. Right? So the complementary solution is going to be y sub c is equal to c1 cosine of 2x plus c2 sine of 2x. Right? So that's the complementary solution. Right? So let's look for a particular solution. So you have a y sub p is equal to, right, we consider all possible derivative of 3x cosine of 2x, right? So you can get the cosine of 2x, and you can get x cosine of 2x. You can get the sine of 2x and x sine of 2x. So what you get is going to be, you're going to have probably something like, let's try about this. I'm going to write it as c1 plus c2 x cosine of 2x plus, right, we're going to have d1 plus d2x sine of 2x. Right? So that will be our first guess. But you can see that there's an overlap between cosine of 2x and cosine of 2x and sine of 2x and sine of 2x. So we would have to multiply the whole thing by just x would probably do it, right? So that you're going to have c1 x plus c2 x squared cosine of 2x plus d1x plus d2x squared sine of 2x, right? And so that is the form of the particular solution, right? So the key is find the complementary solution first. Then we consider all the derivatives of the right-hand side. Oops, sorry, of the right-hand side. Then so list all the possible derivative as a term. Then if there's an overlap between complementary solution and the particular solution, we multiply by a power of x to just eliminate the overlap, so that we know the form of the particular solution. All right, that's it. I hope that this was clear.